Oh, working up a sweat. Hey world and beautiful people living in it. Have you ever wondered what a solution is? A solution is a homogeneous mixture that is uniformly intermingled throughout. This means that one part of the solution is the same as the other on an atomic level. A solute is what's being dissolved in a solution, such as salt. And a solvent, with a V, is what is a dissolving medium in a solution, such as water. I'm gonna do a little experiment here for you guys. Feeling a little frisky. So I'll put the salt in the water, and then I'll use my trusty spoon to stir it up a little bit, and it will dissolve. This means it's soluble, which means it's able to be dissolved. Hey kid, you know what miscibility means?
No, sir, but I'd sure love to know.
Miscibility is how well two or more substances can mix with each other. It's determined by intermolecular forces.
Wow, I'm a master at solubility now. Nuts.
So now that we know what a solid solute is, can you give me a little more insight on what a liquid solute might be?
Well, right here I have ethanol, which is a alcohol. And in my other hand we have water. So when we pour ethanol into water, both liquids are miscible. So they become a solution that is uniformly intermingled on the atomic level. And crop it.
An example of a gas solute would be the breakdown of carbon dioxide molecules within a bottle of Mountain Dew. If I shake this up, it shall explode, leaving me with a sticky mess and having to wash my hands.
Yeah.
There are three factors that affect the solubility of a solvent. First is temperature. As temperature increases, so does the solubility of a substance. In other words, as solids are exposed to higher temperatures, the intermolecular forces are more effectively broken apart.
Second is the actual nature of the solute and solvent. A more polar solute dissolves more effectively in a polar solvent.
And finally, third is the pressure exerted on the solution. As the solubility of the gas increases, so does the solubility.
Okay, so Henry's law states that as pressure of the gas decreases, its ability to dissolve into a liquid shall increase. So, if you apply this to a soda company filling up their pop cans, they will decrease the gas outside of the pop can to get it to dissolve into the bottle. And the opposite shall occur whenever you shake up a bottle and open up the cap. You are increasing the pressure within the bottle, allowing it to effervesce out of the liquid and out of the bottle, escaping into the surrounding air. Effervescence, as we've already discussed with the soda bottle, is the rapid escape of gas from the liquid in which it dissolves. Whenever you shake up a soda bottle and open the cap, it decreases the pressure and allows the bubbles, the CO2, to effervesce out of the can.
The definition of dilution is the process of making a liquid thinner or weaker by adding water or another solvent to lower the concentration of the solute of the solution. The equation for dilution is M1 times V1 equals M2 times V2, and in the equation M stands for molarity and V stands for volume.
So, say you're trying to dilute a substance and you need to figure out how many liters of H2SO4, which is hydrogen sulfate, and H2SO4 has a molarity of 18. So how many liters would be required to prepare 1 liter of a 0.9 molarity solution? There's an easy way to figure that out. You just have to plug in the units. So M1, but in the original equation, would be 0.900 from over here. That is the original molarity. And V1, up in this equation up top, would be 1.00 liters. The volume is often described as liters. And then M2, this unit right here, would be 18.0. That is how much molarity of the hydrogen sulfate. And then V2 is what you're trying to find. After figuring out the respective variables for the dilution equation, you end up with 0.900 molarity, big N, multiplied by 1.00 liters will equal 18.0 big N molarity times the second volume. In this equation, you would want to multiply 0.900 by 1.00, and you will end up with a unit of 0.9 molarity times liters. After you reach this checkpoint, you want to divide by the opposite side, which would be 18.0 molarity. Divide that by both sides, and you end up with 0.05 liters. Right here, during this section, you want to cancel out the molarities, so you're left with V2 in liters, which are your final units. As we get 0.05 liters as our final answer, that means that we need 0.05 liters of hydrogen sulfate to prepare a 1 liter solution with a molarity of 0.9. So the remaining solvent would be 0.95 liters of water. So, say Danny over there dilutes 250 milliliters of a 0.10 molarity lithium acetate to a volume of 750 milliliters. What will the molarity be of Danny's solution? So you have to first break it down by determining what each variable represents. So M1 of the original equation will equal 0.10, a molarity of 0.10. V1 will equal 250 milliliters. M2 is undetermined, it's what we're trying to solve for, and V2 is 750 milliliters. So, as you plug it into the original equation, you'll have 0.10 molarity, multiply that by 250 milliliters, will equal M2 times 750 milliliters. As you multiply these two terms together, you will get 25 molarity times milliliters. And in order to separate M2 by itself, you need to divide by 750 milliliters, so that cancels out. And over here, you'll divide by 750 milliliters, so that the milliliter signals cancel out, and you're just left with molarity. So your final answer to this equation would be M2, the molarity, is equal to 0.0333 repeating. This means that the molarity of a 750 milliliter solution will be 0.033 repeating.
For our real world example, we decided to pick the BP oil spill of 2010 in the Gulf of Mexico.
The oil and water form a heterogeneous mixture which is not uniform throughout, and each is immiscible, which means that they cannot become soluble within each other.
Water and oil also don't mix because water is polar and oil is nonpolar. Stop it. Danny, what are you doing, man? You're the weak link in this group, man.